Alright, section 6.3 deals with graphing the sine and cosine functions. And I've already drawn the graph of the sine function. You can extrapolate these points from what we've already defined the sine function to be for various input values. You can look at the unit circle and see that when you plug 0 in for the sine function, 0 would be what comes out, since it is the y-coordinate on the unit circle over the radius. And then each of these other values also represent a point on the unit circle, and the interesting thing is that once you go through the unit circle one time, you can go through it again if you would like. Or maybe instead of going through it one time counterclockwise, you go through it one time clockwise, which gives you this side of your graph. So sine and cosine are what is referred to as a periodic function because it repeats for, in this particular case, every length of 2 pi in the x-axis. You could take that slice of the graph and just sort of copy and paste it infinitely to the right and infinitely to the left. Now, in my opinion, the easiest way to remember how to graph sine and how to graph cosine is to just simply remember the starting point and whether it goes up or down to the right of that starting point. So I usually start my sine graph at the point 0, 0, and then recall that sine goes up from there, and then I'll be able to make my wave pattern after that. Similarly, cosine, I remember, starts at the peak of its wave, and then it goes down because there's nowhere else to go from the peak than to go down. So that's how I remember which is which. Okay, in this section, problem 19 asks you to use the graph of sine or cosine in order to evaluate this function value. So they're asking you to figure out what is the value of cosine of 8 pi. Well, if we look at this graph of cosine, we see that at 0 it is equal to 1, and then at 2 pi it is equal to 1 again. Or if we were to go backwards, at negative 2 pi it is equal to 1. So every time we get to a multiple of 2 pi, then the cosine value is equal to 1. So it should be equal to 1 when we evaluate cosine of 8 pi as well. Same idea, problem number 20 is asking for sine of 11 pi. Well, if we go back to our graph of sine, we see that at pi, the sine function is equal to 0. And at 2 pi, the sine function is 0. And 3 pi, the sine function is 0. So it looks like every single multiple of pi on the sine graph is equal to 0. So we can conclude then that sine of 11 pi is equal to 0. Alright, similarly, on number 27, they are asking you to do this sort of backwards now. They're saying what angles, what values of theta, when you take cosine of that angle, will give you negative 1. So let's go back to our graph again of cosine, and we see that the y-coordinate is negative 1 at an x value of negative pi, positive 3 pi, and if you follow this pattern out, it would also be 5 pi, 7 pi, and so on. So in other words, theta, a solution for theta for this equation would be pi, 3 pi, 5 pi, 7 pi, and so on. Basically any odd multiple of pi, and of course that also includes the negative odd multiples as well. So negative pi, negative 3 pi, and so on. The last type of question I want to look at in this section is something similar to 31, where they ask you to graph a section of either the sine or the cosine function. In this particular case, problem 31 is asking you to graph y equals sine x, but only for the x values from negative 5 pi up to negative 3 pi. So What I would recommend doing is go ahead and pretend that you're actually graphing the entire wave of the sine function and just put some dots where they belong. So I've marked this up in a way that will help us. So sine always starts at the origin at the point 0, 0, and then it goes up before it comes back down. But we don't want to really go in the right-hand direction in this case because the range of x values that we want is from negative 5 pi to negative 3 pi. So what I want to do then is go from the origin backwards and then just keep making this wave pattern of my dots for as long as I need to. Oh, I missed a dot. So this should be here, not here. This should be here, not here. This should be here, not here. Okay, there we go. That happens once in a while. Alright, then we can fill in this wave pattern, but let's go ahead and label what we have so that we're not connecting the dots for more than what we need to use. So this is where x is 0, and then each little tick mark actually represents half of a pi. So this dot here represents negative pi, and then that's another half of pi, so then this is negative 2 pi. And then this dot right here finally is negative 3 pi. So now I want to connect the dots starting here and going up and then down and then back up again. So if this is negative 3 pi, this is negative 4 pi, and then this dot where we ended is negative 5 pi. So really all that we were interested in is this one piece of the sine function.